Right, so now we are going to do the question from 2010 past paper. So question number 1, so this question number 1 is about unit and dimensions. So units and dimensions. So I'll read the question. So the dimensions of moment of inertia is, so they have given 5 answers: ml squared, ml, m, l, mlt minus 1. So in order to find the correct answer, we have to understand the dimensions and we have to understand the moment of inertia. Okay, so in order to understand the moment of inertia, we should look at inertia. We have to understand inertia. Okay, let's take a look at inertia. Okay, so inertia, okay, inertia is basically about matter and movement. Inertia is the quality in matter that lets it stay still if it's still, or keeps it moving if it's moving. Let me tell you with a basic example so you can relate to it and you can understand it better. So when you're traveling in a car, okay, have you ever noticed how you continue to move forward when it stops? When the car suddenly stops, have you ever noticed that you continue to move forward? Okay, you just jerk, right? So that is inertia. Inertia is the tendency of a body to resist a change in motion or rest. Okay, to resist a change in motion or rest. Okay, so when the car suddenly stops, okay, you just tend to jerk. You just you'll be thrown forward, okay, before coming to a complete stop. So that happens, right? So that is because of the inertia. Okay, in the same way you will jerk backwards, okay, when the vehicle begins to move, when the vehicle begins to accelerate. Okay, so you will jerk backward. Okay, so that is also the inertia. Okay, it is the the work of the inertia of your body. So the phenomenon occurs because of the Newton's first law of motion, the first law of motion. So that is, let's say, a ball. Okay, okay, at rest, a ball at rest, okay, or in motion, will continue to be in the same state unless acted upon by an external force. Okay, so which means objects tend to keep on doing what they are doing unless they are disturbed. Unless otherwise they are disturbed, they will they will tend to keep on doing what they are doing. Inertia is a measure of the measure of the force that keeps a stationary object stationary, or a moving object moving at its current speed. So inertia is a measure of the force. Do you understand, right? So the larger the inertia, the greater the force that is required to bring some change in its velocity in a given in a given amount of time. Okay, let's say suppose a heavy car. Okay, let's say a heavy car or a truck, okay, and a light car are both at rest. Okay, then intuitively we know that more force will be required to push the truck to a certain speed in a given amount of time, okay, than will be needed to push the car to that same speed in the same amount of time. Okay, so now we understood the inertia. Now let's talk about the moment of inertia. Now it's easy for us to understand the moment of inertia because we now know the inertia. Okay, so moment of inertia is that property where matter resists change in its state of rotatory motion. Okay, not the linear motion. Okay, rotatory motion. So the larger the moment of inertia, the greater the amount of torque. In the linear motion we spoke about force. So in the rotatory motion, that force is equal to this torque. So the force and the torque are basically the same thing, but when you consider it in the linear mechanics, linear motion, we termed it as force. We call it as force. It is termed as force. Okay, so in the rotatory motion we call it a torque. So that is the difference. So both are basically the same. Okay, have you seen the movie called Gravity? If you haven't, find a time and watch that movie. Okay, it's called Gravity. In that movie there is a scene. Okay, I'll play that scene for you. You just watch the scene and you just come back. So I'll explain the moment of inertia with that scene, so it'll be more interesting.
Oxygen is going down. It's going down fast. 9. No, 80%.
Okay, you're breathing too fast. You're burning oxygen, and we don't want to do that. We want to relax. Copy?
Sorry. Yes, copy.
I'm nearly there.
Please hurry.
You can holster that torch, Dr. Stone.
Sorry.
Gotcha. All right. Now, I'm going to tether you to me. I know you never realized how devastatingly good looking I am, but I need you to stop staring and help me with the tether. Okay?
Okay. I got it.
All right, here we go. All right. Now to clear you from the jets, I'm going to give you a little push.
No.
Not a push.
No.
A nudge.
No, damn it, no.
So, all right. So in this scene, because of an accident, okay, this accident, rips through the space shuttle, and destroy the whole structure, sending this, astronaut. Her name is Ran. Okay, off into the void. Okay, so off into the space. Okay, so void, space, everything similar. So Ran is actually she's quickly tumbling away through this vast expanse of space with no control over her movements. Because in outer space there won't be any external force. Even the gravity exists, but you will not feel the gravity because of the distance from the earth. Okay, you will not feel the gravity, so there won't be any external forces. Due to that, if you stay still, you will always stay still. If you keep moving, okay, in a direction, you will always keep moving in that direction only. So in that scene, that another astronaut coming from nowhere, he is trying to stop her, and he is trying to tether her and applying some force. Then only she starts moving in a different direction. So you see that rotation. She is rotating. That is because of the moment of inertia. So if the second astronaut, the guy who comes out of nowhere and stopping her, okay, he needs to give force, okay, in order to stop her, because he needs to overcome this moment of inertia. So in order to stop, in order to make it move or stop, whatever it is, in order to overcome moment of inertia, you need force, or you need torque. That's it. Basically inertia and the moment of inertia are basically the same, but they have differences. Inertia is a property of matter which resists change in its state of motion that we already spoke about. Unlike inertia, moment of inertia depends not only on the mass but also the distribution of mass around the axis. That is the point you have to note down. Okay. Unlike inertia, moment of inertia depends not only on the mass but also the distribution of mass around the axis. Okay. About which the moment of inertia is to be calculated. Okay, let's talk about the dimension. Okay, so every calculation or every measurement, let's say every measurement you see in the world has two parts. Every measurement in the world you see has two parts. Okay, the first is the number, and the next is a unit. Okay, for example, let's take weight of an object is, let's say, 25 kilogram. So the number 25 expressing the magnitude of that physical quantity. Okay, and it is inversely proportional to the unit selected. So this is the unit. So let's say like 5 meters, 35 kilogram, anything. If you take anything, 25 meters second minus 1, anything, you take anything, there'll be a number and there'll be a unit. Okay, so in order to understand the dimension, we need to understand the quantities. So basically there are three types of quantities: fundamental quantities, and supplementary quantities, then derived quantities. Okay, so there's a list, right? So the quantities that are independent of other quantities are called fundamental quantities. So that is the definition of the fundamental quantities. Okay, so the quantities that are derived, using these fundamental quantities are called derived quantities. So these are the and the supplementary quantities there, it is always attached to fundamental quantities. Okay, so the fundamental quantities are basically length, mass, time. Okay, so length, mass, time. Additionally, like we have electric current and temperature, intensity of light, quantity of substance. So for length the unit is meter, for mass the unit is kilogram, for time the unit is second. Let's now talk about dimensions. So what are dimensions? For this, don't take your notebook or maybe your syllabus and just read the definitions. For science, to understand the science, you have to study the examples. Then only you can relate to that subject matter. Then you can understand completely. If you just read the definition, you will not understand properly. So the best way is always connect it with real life scenarios. Okay, so here I'll explain you. The nature of physical quantity is described by nature of its dimensions. Okay, in simple terms, when we observe an object, the first thing we notice is the dimensions. In fact, we also defined or observed with respect to our dimension, that is height, weight, the amount of flesh. Okay, yeah. So the dimension of a body means how it is relatable in terms of base quantities. How it is relatable in terms of base quantities. So when we define the dimension of a quantity, we generally define its identity and existence. Okay, right. So I'm gonna draw a rectangle. In 2D and in 3D, so we can compare the 2D versus 3D. Okay, so we can understand the dimension from it. So here the rectangle, so it has the length and the width or the breadth. Okay, and here the rectangle in 3D. Okay, it's a cube actually. Okay, so it has length, breadth, and the height. So dimensions are responsible in defining shape of an object. Okay, you have to note down that. Now you can understand completely the dimension. Okay, you can understand the dimension very well, because these quantities are intangible. You can't see, you can't touch, you can't feel, so you can't understand. So if you study the definition, you will not understand for sure. So for that we have to study these properties with examples, then only we can relate to it and we can understand it. So dimension of length is described as L. Okay, and the dimension of time is described as T. Okay, and the dimension of mass is described as M. So in order to find the dimension of a quantity, we should know either the formula of that quantity or at least the unit of that quantity. So with that formula we can find the dimension of it. Okay, based on that formula. And if we have the unit, if we know the unit, then we can derive the dimension from that unit as well. Let's go to the question. So in this question they are talking about moment of inertia. So we have to know the formula of the moment of inertia. So what is the formula of moment of inertia? That is I equal to mr squared. Okay, so from m, okay, the dimension for mass is m, capital M, and for the dimension of r is a radius, that's mean it's a length, right? So it's L, the dimension for the radius r is capital L. Okay, and the radius is not just a radius, it's a radius squared, so we have to add the square here. So ml2 ml square, so that is the answer. So that is the first answer here. So this is how, okay, we are going to dissect each question and we move.